Hi everyone, it's me, Carolyn, and in today's video, we are going to continue our discussion on the normal curve by looking at how we relate a normal problem out in the real world to that standard normal. In my previous video, we did discuss the standard normal with the mean of 0, standard deviation of 1. And we learned how to use the table to find areas under the curve, which are also probabilities. Now, you can use technology to do so. There is a function in StatCrunch, so you'd go under the calculators and find that normal calculator. Or you can use your graphing calculators. There's functions on those as well. Excel also has a function. I believe it's the normal function, and it's probably normal PDF. And we can go from there. But I'm going to work on the table, because that's a little bit still old school. And I think it's used a little bit more than some of the technologies, especially in testing situations, because it's so easy. It's a little bit easier to control. But anyway, let's share our screen and we'll go to our guided notes. And we'll look at this, here we go. The section 7.2, and this is the second part of it, because the first part was all about the standard normal. So the mean of 0, standard deviation of 1, and we learned how to use the table. So today we're going to be making that connection between a regular question, a regular problem, and that standard normal. And that connection is by going through that z-score that we learned earlier in the semester as well. So here's my example that we're going to start with. We have the number of chocolate chips in an 18-ounce bag of cookies is approximately normal, with a mean of 1262 chips and a standard deviation of 118 chips. Now, this information was probably gathered from years and years of past creating of our cookies, measuring how many chips were in there, counting them. And they could also, by graphing the number of chips in a bag, find that it is approximately normal by looking at a curve. But since it is approximately normal, and that is something we need to be told, otherwise we really can't use a normal curve to deal with these problems. But since we have a normal curve, we can ask ourselves some probability questions. So I just randomly make these questions up. I randomly make up this information too. So I don't know if there's 1262 chips in an 18-ounce bag. Or if it has a standard deviation of 118. They're just numbers, arbitrary things, but out in the real world, there is real data that does use this material. So what is the probability of a randomly selected bag is going to have somewhere between 1,000 and 1,400 chocolate chips? Again, I like to draw pictures to help me visualize what I'm trying to do. So it is normally distributed, okay? And the normal curve is always centered around the mean. So that 1262 is going to be smack dab in the middle. And then I like to put the other numbers that I'm concerned about in my picture as well. So I'm looking for between 1,000, well, 1,000 is on this side, and 1,400, which is on this side. And I put them in here. So there's my 14 and my 1,000. And we're looking for between. So again, probability of something is going to be the area of that same region. So we need to find the area under that curve. Now, we don't have tables for every single situation. So the magic thing to do, and it is kind of magic or mathic, if you want to call it that, is we go through our z-scores. And a z-score is a way to kind of standardize our values. So what I'm going to do is I'm going to take these two boundary values and I'm going to standardize them or find their corresponding z-score. So again, to remind you of the formula, and I'm writing it in words. I'll write it in symbols as well. It's your x minus your mean all over your standard deviation. Okay, so we're going to do it for both the 1,000 and that 1,400. So I'm going to take that 1,000 minus my mean and subtract it by my standard deviation, which is 118. And then I am going to round this to 2 decimals. And the reason I round to 2 decimals is because our table, our standard normal table, has 2 decimal places. If I were working with something that had more decimal places, I would go further than just the negative 2.22. So decimal. Okay, I'm going to do that as well for my 1,400. So that 1,400 minus the mean all over the 118. And so calculator, do your thing. Life got so much easier when we didn't have to do all that long division by hand. And again, I rounded to 2 decimals because that's what my table has. So what we've kind of done is we've taken this curve and we have turned it into the standard normal. So if I were to do this 1262, that would go to this 0. This is negative because it is smaller than the mean. And here's my 1.17. So now my picture, of course, is a little bit not drawn to scale, but that again doesn't make a whole lot of difference because we're using it for reference. We're not actually doing it for complete measurements. All right, so now we have to remember, how in the world do we use the standard normal table to get this area? So we remember that we're going to be looking up these 2 values. So we're going to look those 2 pieces up. And realizing that these are z values. And getting those values from our table. So they are a z because they're down on this main line. They're not areas. We're looking for areas. Areas are inside the table. Z's are on the outside. And the first one I'm going to look up is a negative 2.22. So we go again, the negative 2.2. And we have to find that second digit by going over. So there's my negative 2.22. So 0.0132. I'm going to also look at 1.17, which is on the other page. 1.1, I think I can get it in the screen here. 7 is 0.8790. 0.8790. And now if you can remember, the table always gives us the area from that point to the left. So if I'm looking at a picture, the area from here down is that 0.0132. The area from this point all the way down is 0.8790. So to find the area between them, we have to take our large area, which includes this piece as well, and get rid of that. So we're going to actually do our subtraction. And come up with 0.8658. So that would be the probability that a randomly selected bag contains between that piece. We can also think of it as a percentage. You can think of it that about 86.58% of all the bags produced are going to have chips in that region as well. So kind of remember the relationship with probabilities and percentages and all the different terminology that we can use. All right, let's do another one, since these are so much fun. Okay, what is the probability that a randomly selected bag of cookies contains less than 1,100 chips. So again, I like to draw pictures. And now sometimes my normal curves don't always look like they're normal. And I'm guessing as you draw them as well, they won't always look beautifully symmetric, but that is okay. The things that are important is making sure you put the mean in the middle. And the only reason I do that is, especially on these tails like we have here. So less than 1,100, so that's going to be on this side. We want to go less than, so that means smaller. Okay, so by looking at my picture, I already know that my answer is going to be less than 0.5. And the reason I know that is because half of the graph is 0.5. And if I went up above here, it'd be 0.5. And since I'm shading in this direction, it's a little tail, so it would be less than 0.5. If I were going bigger, it would have been more than 0.5. All right, so again, our technique is to standardize this 1,100 or find the z-score for that 1,100. So that's 1,100 minus the 1,262 divided by the 118. Getting my calculator out and punching my buttons, I get a negative 1.37, and it should be negative because we are smaller than the mean. Our next step is we're going to look this up on our table. And remembering this is a z-value. So a negative 1.7 is 0.0853. 0.0853. Okay, so here I can say that if I'd gotten a bag with less than 1,100 chips, that's not considered to be unusual. Remembering unusual means less than 0.05. So there we are. Okay, let's do another one. I've got a couple more. And let's see, we have an 8, again, the same chocolate chip. We want to have more than 1475. And again, it is important to make sure you read carefully questions and make sure that you shade the correct way. You put your pieces in the right spots. We're going 1475, which is on this side. And I want to go more than, so more than, oops, I should probably put 1475 in there. More than is in this direction. So now we're going to find the z-score for that, which is going to be that 1475 minus the 1262, the mean, divided by our standard deviation. And then we go to the calculator. Make sure when you're doing it on the calculator that you do use the correct order of operations. I usually do my subtraction, get that value, and then take that number and divide it by the 118. So just make sure you can calculate those. So maybe practicing with this video to make sure that you get the same values that we do. Also making sure you can use the table, read the numbers correctly. So now I'm looking for a 1.81. So 1.81, making sure you do go past the first one. That's another common error that students make. This would be 1.80 here. So we need to go to this guy to get this value. So 0.9649. 0.9649. So we're going to the table. All right, but that's not our answer. Because first of all, I could look at my picture. Well, it's got to be less than half because I'm less than half of the graph. But the table, remember, gives us from here all the way down. So to find the area above, the thing we have to remember is the total area under the curve is 1. This is a probability distribution. So we would subtract that from 1 and get 0.03 3.51, or as a proportion, roughly 3.51% of all the bags would have more than that number of chips. So this would be unusual for us to have more than 1475. Okay, another way to ask similar questions. Let's say, what percent rank is a bag? Another typo, sorry about that. A bag that has 1342 chocolate chips in it. And of course, spell check didn't catch it because there is such a thing as a bog. But what percent rank is a bag with 1342 chips? And so I'm going to kind of, again, I like to draw my pictures. There's my 1262. 1342 is up here. Okay, so we're looking for percentile rank. Now, remembering percentile is a position that finding the percentage of kind of a placement thing that you and finding out what percent score at or below you. So here B has 1342 chips or fewer. Our answer is going to be bigger than our 50 percentile because this guy's right in the middle. So this is our 50th percentile. Is that point, that 1, 2, 62. So we're above him. So we should have a better than 50% ranking. But again, we're looking for people below you, at or below you. So we will find our z-score. So that 1348.42, sorry, minus our mean divided by our standard deviation. And I do get just 0.68 here. I guess I probably could have put them a little closer. That's okay. This is a z-score, a z-value, value on the main line. So we're going to go to the table and find the area. So, or the probability, or the percentile, or the proportion. 7517. So if I looked it up here for you guys, 0.68, oops, way over, 0.7517. So in top of percentile rank, that is the 75th. And depending on how many decimals, that's 75.17th percentile. Okay. We're going to switch gears just a little bit. And let's say that we have that the company decides to discard or throw away. They can always throw in my direction. And the lower 8% of the bags for having too many chocolate chips. And they had this chocolate chip magic chocolate chip counter or something. And they kind of need to know how many bag chips does it have before it's not going to be discarded. All right, so I'm going to draw my picture. Again, we are still working with a normal curve. That doesn't change. It's still centered at 1262. But we're going to discard the lower 8%. Now, 8% isn't the number of chips. That 8%, I'm doing the lower 8%, is that piece right there. So we're getting rid of that. And we're looking for how many chips. So we're looking for that number right there, the number of chips that go along with this little tail of 8%. 8% in its decimal form is 0.08. So that is an area under our curve. So now we are on this side of the mean. So if I'm looking at the z-scores, so we're going to kind of go backwards. So it's kind of going backwards. I have this piece. So now I'm going to go to my z-score. So I have the area. I need to find, first of all, the z that goes with it. So we have an area of 0.08. Need the z value first. And it will be a negative value because we are on the lower side. And I'm going to be looking for 0.08 inside here because it's an area. And if I kind of just kind of glance here, and here's my 0.08 kind of here, but if I go this way, I'm going the wrong direction, but actually, so 0.0808 and 0.0793, this one is 7 away, this one is at 8, and doing my subtraction in my head. So this one is actually a little bit closer to the 0.08 because it's like 0.0007 away. So my z value that I'm going to use is a negative 1.41. So the negative 1.4, and then I went up to get my 1. Now what we have to do is find that value. So I like to call this process unstandardizing. I think those are my terms. I don't think I've ever read them anywhere, but we want to find the actual data value. So if I write this into my formula, because I remember z is equal to x minus mean all over standard deviation. I have my z. I'm looking for x. I have my mean. Okay, and now I have to remember a little bit of algebra. The first thing I'm going to do is get rid of my fraction by multiplying both sides. Multiply both sides by the 118. When I do that on this side, that's going to cancel the 118 here. So I'm going to take, and I'm going to do that negative 1.41 times my 118. And if I do that on the calculator, I get a negative 166.38. And that is equal to my x minus 1262. And now to find x, we will add 1262 to both sides. So we do have to remember a little bit of our algebra skills to solve these. A lot of times textbooks also have these formulas written down somewhere for you. And if I add those using my calculator, so I don't have to do all the work myself. So in other words, a bag must have more than I don't know how it would have a partial chip in there, but as long as we're at 1096, we would keep you. 1095, you'd be discarded. Okay. So there's one example of kind of going backwards for us. All right, we're going to do another one with our bags of chips and our bags of cookies, and then we'll switch to a different problem. And me personally, I like to have a lot of chocolate chips in my cookies. Some people don't. I tend to be that person that likes lots of chocolate chips, but I've decided I only want to eat the top 2% of these cookies. So I want to know how many chips have to be in the bag before I'll eat them. So here's a similar problem, but instead of looking at the bottom half, we're going to be looking at the top half. So that's my 1262. I'm looking for the top 2%. So again, the 2% is an area. So I'm looking for this guy right here. 2% as a decimal is 0.02. Okay. But remembering that the table gives us values from a point to the left. So if this is 0.02, the rest of it would be the other part, or the 98%, or 0.98. I also know that I'm at the upper side, so I'm going to be a positive z value. So this is going to have our area. And the area that we're looking up is actually that 98%, that 0.98 to get the Z. The 0.02 gave us the 0.98. And now we're going to use our table to find our Z. So we're looking for 0.98. Let's see here. There's a 9783. Getting closer. There we go. There's a 9798 and a 9803. The one that is closer is this one, because it's like just 2 away from there. This guy has got 3, a little bit. This one's just a tad closer. That's 2.05. 2.05. Okay. And now what we do again is Z is equal to our X minus our mean all over the standard deviation. Our Z is this 2.05. We are looking for the X, the number of chips in our bag. Our mean is at 1262. We've been working with the 118 for a long time. And now we're going to follow the same steps that we did previously do. So we're going to multiply both sides by the 118. I'm not going to write them all down again. So we're multiplying by 118. And I come up with 1241.9. I will then add my 1262. And I come up with 1503.9. So for me to eat the bag of chips or bag of cookies, sorry, it has to have at least 1503 chips in there. 0.9, so probably 1504. If there's 1503, I'm going to be a little disappointed, but I probably still be okay. All right, let's do another example. And this is something probably a little bit more realistic in nature. We have a certain exam that's normally distributed with a mean of 72 points and a standard deviation of 4.3. And we want to find the score that would represent the 7th percentile, because maybe there's funding for something if we have enough people in that bottom region. Or, you know, a lot of times if we have too many in the low rankings, like for ACTs and things like that, they use a lot of statistics to kind of work with those sorts of testing. So here we go, 7th percentile. Our mean is 72, so that's going to be smack dab in the middle. Standard deviation of 4.3. 7th percentile means we're looking for a score, so we're looking for a value on the main line. And the 7th percentile is a small piece. Remembering, here's our 50th. We're going to be on this side. So somewhere over here, where this is 7%, or 0.07. And we're looking for our score. So we will be doing a similar process that we just did. All right, which means we're going to be on that negative side, and we're looking for that 0.07. There's 0.06. That's going the wrong direction, so we got to go down this one. 0.0708. There's our value. 0.0694 is closer than this one. So a negative 1.48. Negative 1.48. So setting up our equation. I will multiply both, whoops, not 118 anymore. It's 4.3. And our mean is 72. So I can put those values in there. So we're going to multiply by that 4.3 first of all. And then we want to add 72 to both sides. And adding 72 gives me a score of 65.636. And that would be the score that represents the 7th percentile. We could do more of the exact idea, but I'm going to actually stop here and end this video. So I'm going to stop sharing. In the next video, we will move on to chapter 8, which is going to start looking at, instead of looking at an individual bag of chips or an individual person or finding an individual score, we're going to start looking at what happens if we look at samples of groups of people and calculate the mean. What does that going to look like? But that is in the next video. So I will see you guys all there.